The main topic in section 1.2 is learning how to graph linear equations. But before we begin that, I'd like to start off by reviewing a few examples of solving equations that have one variable. Here's an example of a linear equation with one variable, and we'd like to solve for x. Now the first step is to remove parentheses by distributing. The negative 2 has to get distributed through these two terms, and on this side of the equation, negative 1 has to get distributed through those two terms. So that would give us 7. Negative 2 times 5 is negative 10. Negative 2 times negative 4x is plus 8x. Then you'd have equals 3x. Negative 1 times 8 is minus 8. And negative 1 times negative 3x is plus 3x. At this point, you would combine the like terms that are on the same side of the equation. Doing that would give us negative 3 plus 8x equals 6x minus 8. Once we get to this point, we want to eliminate one of the variable terms. So if we subtract 6x from both sides of the equation, we would get negative 3 plus 2x equals negative 8. Since the x ended up on the left side, we'd like the numbers on the right side. So if we add 3 to both sides, we have 2x equals negative 5. And then dividing by 2 gives us the final answer. X equals negative 5 halves. Next, we'll try one with some fractions. Now, when you have fractions in your equation, you have to get a common denominator in all the terms. Now, in this case, you see the denominators are 4, 8, 2, and 4. So the common denominator would be 8. So first we have to rewrite the equation so all the fractions have a denominator of 8. That means in the first fraction we'd have to multiply the numerator and denominator both by 2, which would give us negative 6 over 8y. The second fraction already has an 8, so it doesn't have to be changed at all. Third fraction we'd have to multiply the numerator and denominator by 4, which would give us 12 over 8y. And then we'd multiply the top and bottom by 2 in the last fraction, which would give us 2/8. Now once we have a common denominator, 8, we can multiply both sides of the equation by 8. What that'll do is it'll make all the 8's drop out. And we'll just get negative 6y minus 5 equals 12y plus 2. Now this new equation doesn't have any fractions, so it's much easier to work with. We'll add 6y to both sides to eliminate one of the variable terms. And in this case, the variable term ends up on the right side of the equation, so we'd like the numbers on the left. So we'll subtract 2 from both sides. It gives us negative 7 equals 18y. And then when we divide by 18, we'll get our final answer. Y equals negative 7 over 18. This next example is called a literal equation because it actually has 3 variables, x, y, and z. The instructions tell us to solve for x, which means get the x alone on one side of the equation. Before we can do that, we'd have to first distribute the 3 through the parentheses here, which would give us c equals 3x plus 3y. Now we're trying to solve for x, but before we can do that, we have to isolate the term 3x, meaning get the term 3x alone on one side of the equation. So we'll subtract 3y from both sides. That gives us c minus 3y equals 3x. And then we'll divide both sides of the equation by 3. Now when we divide the left side by 3, we have to divide the entire side by 3. And that gives us our answer. X equals c minus 3y divided by 3. Now we're ready to discuss the main theme of this section. which is graphing a straight line, or graphing a linear equation in two variables. Now in the last section, we discussed how to make graphs to show the relationship between two variables, an independent variable and a dependent variable. And in that section, we used different letters for those variables to stand for what they represented. But it's typical that when we're not working with a real-life application and just kind of practicing with a generic problem, the x would always represent the independent variable and y would always represent the dependent variable. So that means we'll label x on the horizontal axis and y on the vertical axis. Now when two variables are linear related, they can always be represented by an equation of the form y equals mx plus b, where m and b could be any constants. So for example, let's work with the problem y equals negative 3x plus 4. In this case, m would be negative 3 and b would be 4. Now, because it's of the form y equals mx plus b, we know this is a straight line. And in order to graph it, we just need to determine some of the points on the line so that we can connect them. 2 points is minimally enough to determine a straight line, but it's useful to have 3 or more points so that you can check to be sure they're straight. And if you've made any mistakes, you'll be able to catch it that way. Usually we find these ordered pairs by making a table, and we let the first column be x and the second column be y. And since x is the independent variable, we can use any numbers we want for that. Simple numbers would be like 0, 1, and 2. And then we plug those in for x and we solve for y each time. So when x is 0, y would be negative 3 times 0 plus 4, which would be 0 plus 4, which equals 4. When x is 1, you'd get negative 3 times 1 plus 4, which would be negative 3 plus 4, so positive 1. And then when x is 2, you'd have negative 3 times 2 plus 4. That'd be negative 6 plus 4, so negative 2. And each one of these rows represents an ordered pair on the graph. So for example, this first row, the x is 0 and the y is 4. So the ordered pair is 0, 4. So we can plot that on the graph right there. And then in the next case, you see when x is 1, y is 1. So we can plot that as an ordered pair 1, 1. And then we have 2 and negative 2. So we'll plot that. We'll go over 2 and down 2. And you see these 3 points do line up straight, which tells us we've done it right, and we'll go ahead and connect them with a straight line. And that's basically how you can graph a straight line by hand. Let's try another example. Notice in this second example, the number in front of the x that's multiplied by x is a fraction, 2/5. And when that happens, it's useful to pick the x values in our table that are multiples of the denominator. Now multiples of the denominator would be like 0, 5, 10, 15, 20, or you could use negative numbers like negative 5, negative 10. So I'm just going to use negative 5, 0, and 5, which seem to be the most simple multiples of 5 that are kind of close to the middle of the graph. And when we substitute those in, we'll get 2/5 times negative 5. Now that will come out to be negative 2 minus 1. So that comes out to be negative 3. And 2/5 times 0, of course, is 0. Minus 1 would be negative 1. And 2/5 times 5 will come out to be 2. And then minus 1 would be 1. So we've got, again, 3 different ordered pairs that we can plot. the top row, the x is -5 and the y is -3, so we'd plot that by going 5 to the left and down 3. And then we have 0, -1, so that means you don't move left or right at all, but you go down 1. And then 5, 1, meaning we go to the right 5 and up 1. And you can see these points line up nice and straight, so I'll connect them with a straight line. Now the calculator can be very useful in generating a list of ordered pairs as well as graphing a line. The first step would be to press y equals in the top left and enter your equation in. In this case, since the fraction 2/5 is in front of x, you should put that inside parentheses. Now once you've got the equation in, it's time to set up the table. So you press second and then the window key, which is the table set. And you enter in what x value you want to start at. And we'll start at -5 because that's what we did just a minute ago when we did this by hand. And right underneath that, it's like the increment, how much you want to let x go up by each time. And we'll go up by 5s because remember we were using multiples of 5. So that would go from -5 to 0 to 5 to 10, etc. And then second graph creates that table. And you can see the list of ordered pairs that we generated are right at the top of the list. And there's some other ones there as well. This list is actually infinite. You can scroll backwards or forwards to see more ordered pairs. And you can also use your calculator to graph the equation by pressing the graph key in the upper right. And if you hit zoom decimal, which is number 4, you will be able to use the trace key a little bit more effectively to see several different ordered pairs that are on the graph. So if you hit this trace key right next to the graph key, and then use your right or left arrow key to scroll along the curve, you can see the ordered pairs are listed at the bottom of the screen. Okay, let's look at another example. In this example, the equation is not in the form y equals mx plus b. So you have to do some work to put it into that form first. So if we first distribute to remove the parentheses on both sides, we'll get 2y minus 6 equals 4x plus 4. Now since we're trying to put it in the form y equals mx plus b, we want to get the y alone on one side of the equation. But before we can get y alone, we need to get the whole term 2y to be alone. So the first thing to do would be to add 6 to both sides. That would give us 2y equals 4x plus 10. Now to get y alone, we need to divide by 2 on both sides. Now on the right side, we could divide the entire side of the equation by 2, but equivalently, we can divide each separate term by 2, which would be more useful for us since we're trying to get it into the form y equals mx plus b. And when we simplify this down, we end up with y equals 2x plus 5. Now it's in the form y equals mx plus b. We can make our table as usual and produce some ordered pairs. If we just use 0, 1, and 2 for our x's, and then solve for y each time. If x is 0, y comes out to be 5. If x is 1, y comes out to be 7. And if x is 2, y comes out to be 9. So the ordered pairs would be 0, 5, 1, 7, and 2, 9. And you can see those do line up nice and straight, so we'll connect them with a straight line. I'd like to do another example. This time we have some decimals in the equation. Y equals negative 4.1x plus 8.7. Now I'm going to use my calculator to help me create some ordered pairs, which will make it easier so that I don't have to do that table by hand. So first we'll enter the equation in under y equals. So it's negative 4.1x plus 8.7. And then we'll do second window, which is the table set. That's how we set up a table. And I'm just going to start the x values at negative 2 and go up by 1s each time. And so we'll do second graph to get those to table. Now the first couple of points might not fit in my graph paper because the y coordinates are over 10. So I'll start with the third one down, 0, 8.7. I'll go ahead and plot that. I'm going to estimate a little. And 1 and 4.6. And then 2.5. And then 3 and negative 3.6. And 4 and negative 7.7. And you can see they do line up nice and straight, so I'll connect them with a line. And I've also graphed it on my calculator, and I'm going to do a zoom decimal once again so that we can trace and see some of the ordered pairs along the line. And if you don't see the cursor on the screen, that means it's off the screen. You can hit your right or left arrow key to move it around, and you see it's on the screen now. And you can scroll through various different ordered pairs. Now another zoom that I like to use a lot is called zoom standard. So if you hit the zoom key and then number 6, which is zoom standard, what that does is it scales your axes so that both the x and the y axis go from negative 10 to 10, just like it does in our graph paper. So that's just kind of a basic scaling system. Now I'd like to go over how to find x and y intercepts. As you remember from the last section, an intercept is a point where the graph intersects either the x or the y axis. Let's take the example 5x minus 4y equals 20 and see if we can find both the x and the y intercepts. Now the y-intercept is a point on the graph that's right on the y-axis. So its x-coordinate would have to be 0. So that's how we find the y-intercept. We let x equal 0 in the equation and then we solve for y. So in our case that would mean we would have 5 times 0 minus 4y equals 20. And since 5 times 0 is 0, we just get negative 4y equals 20. And then when we divide by negative 4, we get y equals negative 5. Now, an intercept is always an ordered pair. We started by letting x equal 0, so x is 0, and we solved for y and got negative 5. So the ordered pair is 0, comma, negative 5, which would graph right here on the y-axis. Now similarly, the x-intercept is a point right on the x-axis, meaning its y-coordinate would have to be 0. So to find this, we let y equal 0 and then we solve for x. So we substitute a y equals 0 into our equation. Now 4 times 0 is just 0, so we end up with 5x equals 20, which when we solve that, we get x equals 4. And our ordered pair, again, remember we started by letting y equal 0, so y is 0, and we solved for x and got 4. So it's 4, comma 0. That graphs right on the x-axis right here. And once we have those two intercepts, if we connect them, that's one way of graphing a straight line. The last thing I want to go over today is the equations of horizontal and vertical lines. Those equations look a little different than the average y equals mx plus b line because they're special cases. Now for horizontal line, the equation will always be of the form y equals some constant, where the constant can be any particular number. For example, you might have y equals 5. Now one way to view that in a table form is that y always equals 5 regardless of what x is. So x could be any number. I'll just fill in 0, 1, 2. And if you plot those points, you see that they're lined right up along a horizontal line. So that would be the line y equals 5. Now similarly, a vertical line will always have the form x equals some constant. So for example, you might have x equals 3. Now again, if you think in terms of a table, that means x will always equal 3, no matter what y is. So y could be any number. So if I plot these points 3, 0, 3, 1, 3, 2, you see they're going to go right up along this vertical line here. And that would be x equals 3. And that concludes today's lesson about graphing straight lines.